Hello. In previous videos I've used this TL494 board. It's through hole, kind of easy to modify, and I've just used it for a breadboard. I mean, you can get these connectors that go right onto it. Makes a really neat looking project, but you don't need to have that. It appears this board is no longer available on eBay. It's still on Amazon, but they're getting almost triple the price of what you used to be able to buy these for. And you don't really need it. This is the basics. This is the pin out. This is looking at the bottom of the chip. You can identify pin number 1 because it will have a dimple, or there will be a notch at the top of the chip. And just put it in a socket. I suggest using a socket because you may do something wrong and you'll blow out the chip. So buy a couple extra chips. I get like 10 of them for $1.50. So if you look around, they're pretty cheap. And if you blow one out, that allows you to just pop another chip in instead of having to resolder everything again and maybe making some new other mistake. So basically you're making some jumpers from 12 to 11, 10 to 9, 12 to 8. This is your 12 volt line, and you have a little 100 microfarad capacitor here, and that goes over to 7, which is your common, and the common goes up to 4 and also goes up to 16. This is your 5 volt ref line, and so these three are tied together, and this is the op amp input, and one side is referenced to 5 volts and the other looks at the incoming voltage from this voltage divider. Now I don't know what resistor you'll have. I got 4,300K resistors, so I use those for everything. But if you have a 270 or 470K, you can go to the online calculator and put the highest voltage that you want your panel to be at. Use say the open circuit voltage, and calculate. You'll know what resistor you have here, and then just calculate what this resistor has to be. Now you can use like a 10-turn pot for the entire resistance, or you can figure out the resistance for the highest value voltage and the lowest value voltage, and that'll give you about how much the pot should be, and then you can just fit in a little resistor down here, and that'll allow you to use not only a 10-turn pot but just any old regular pot. If you try doing it for the entire resistance, a single turn pot will be very touchy to adjust. So anyways, on the other videos we're driving 2 FETs. I like to put a little resistor, 10 to 33 ohms, anything. It's not that critical. The 10 and 9 are the emitter of the internal transistors, and they feed into this pull down resistor. Around 750 ohms, 1000 ohms would be okay. And this is your minus common line, and this is the timing capacitor. It's a 4N7. Anything around that range, preferably a little bit higher, and use a 1 megohm resistor, or you can use your timing calculators on the data sheet. Now up here we have another capacitor. It's not really critical. If you're buying 4N7s, you can use that here. It's just a filter to the input of the op amp. And that's about it. Now, if you have a 12 volt battery system, you can run this just off 12 volts, and you don't need to have the Zener. But if you're running from the panels, you'll need the Zener, and you need to put a resistor in, and you want to figure out the resistance out for a 20 milliamp current draw. And so you take the panel voltage minus the 12 volt for the Zener, that's the voltage you're trying to drop here, and divide by 20 milliamps, and that will give you the resistance. So figure anything close to that value will be okay. But that's it. It probably takes you less time than do the modifications. It may not be as pretty, but this will do the job. So I hope you all try this. So thanks for watching. Any questions? Please ask.